Well, should we get started and work through our list on the demo things? I'm gonna present my screen, entire screen, that one, share. Everyone see that in this notepad, and yeah, okay, good. So the things we had on the list were clone, Tajson, rest allowed, act as expressions, and we had a now view and view. I'm gonna add debugger as well. So let's get started on the clone thing. Really common need is to duplicate structures of data and not only a single object, because a single object or even a structure you could always do with the code and OCL. You create one of those and one of that, and then you copy the attribute from the original one to the new one and do that for each attribute. And that of course builds up to a lot of boilerplate code that just needs to be done. And as we had this need for object structures that could be really any depth, we thought of different ways to do that, and maybe we could just follow the aggregation information on the model. So if you copy a thing, you should follow the aggregation and also copy the details if you want to do a deep clone of something. And that might be fine, but maybe you would like to pull in some things that aren't aggregated as well, depending on the use case. And definitely depending on the use case, you might want to copy only part of the attributes. You don't want to copy the identity of an object, but you want to copy all the boilerplate attributes for that comes along. So as we had that need, we thought about a way to declaratively describe how to define how deep to go and where to go in the copy. And as we are totally insanely into view models and declarative description of object structures that way, we thought that a pattern based on a view model would be great. So that's what's behind the introduction of the deep clone operator. And basically it would work like this, that I create a template for what I want to copy with my clone. So let's say that I want to clone deep clone a thing. I would do a view model that I would call anything, but just to keep track of it, I would call it thing deep clone 1. Could be many depending on use cases, and I'm going to type it to be of type thing, and then I can just describe what are the attributes that I want to copy over to a clone of this. And I want to take these attributes, and now I'm only taking them straight up. I could of course do some transformation if that was what I wanted. And now I also can follow the multi-links and pick all the details. So all the details in the original would be created, and from that I want to copy the attributes as well. But I might not want to copy all attributes, so I'm going to leave the number 3. and I can do this for other things as well, as the single link some value that will be 1, so that would be copied. That wouldn't be that super smart, but let's leave it like this for now. So what should ideally happen is that the original object comes in and is set as self, and we evaluate all the expressions for that object structure, and we look at that and create a duplicate of the thing and assign these attributes to the rendered values. And how would that look? Well, let's add an action on this level to call the deep clone function view model action. So this will try to deep clone, and the execute expression would be based on the selected thing I have in the grid, and I would call the operator called deep clone. That takes a view model, and of course that would need to be of the type thing, and there's a static collection that's maintained with all the view models that are rooted in this class called view models, and there I will find all the view models that the model sees currently, and I want to use this thing deep clone 1. And what will happen is that this will return a new object of the same type that I send in, and it will follow the patterns from the deep clone and possibly then create detailed objects as well, as that is what is described and stipulated in the view model pattern. And that's all there is to it. So let's try and run this one in XML2. And first I'm going to create one thing then, and let's add some values here to make sure that we skip that one. Add some details, like take 3, 1, 2, 3, 1Q, 2Q, and 3Q, 1, and like that. So this is a unique thing, and if I try to deep clone that one, a new one was created. Of course it will have the same attributes, it will be unsaved. I'm gonna view that one, and now I see that all the attributes have been copied over except the attribute 3, which I left left out of the view model pattern. And as I said, if I wanted to do some transformation here, I could do that by changing this expression to new, like that. They say that I shouldn't take the value from the original straight off. I should instead take the value from the original and append new behind it. And refreshing, okay, I'm gonna, And if I now press deep clone on this one, it would be following that rule instead. And of course I could do that on all these as well. So it's a really effective and good pattern to use, because we typically use it, you have this pattern of revisioning of things. You have a certain definition, and then the users want to change a few things, but they want to remember the old values. And we're going to do a new revision, and the revision might be really detailed and an object structure really that follows a lot of associations and has a lot of attributes in different places. Doing a deep clone view model really simplifies the one common place where you have this copy, and because that's the naive way is just to bring up a blank form for the new revision, but our users at least will totally explode at that and will say that well, I want the old values from the old revision to start with, and I only want to change a few things. I don't want to do it all over. So that's a good tip. Have you, has anyone used that one before? Yes, Emily, I know you have.
Can you bring up the view model? There's a few more things. Are you planning to point them out, Hans? I really love these features. I would like to point out a few more things. One is that usually you don't have placing hints on when you use this, because you don't build a user interface. And then you turn on duck type checking. Where is that one? Yeah. So here you can, because how this works is that it just matches a name of the column, the view model column. So for example, some datetime will be looked up based on the name in the receiving object. So if you put the duck type there as a thing, it will check. And now you might wonder, but it's always going to be the same. Well, not really, because you can actually use another operator called transform, and then you can have a different receiving class. So you can transform, for example, an order to an invoice by defining how that transformation should happen, and you can also provide the receiving object. So in transform, you use view model and the receiving root object, and then it will work from that. And all the navigations and everything will be based solely on the new structure. And that's why this duck type comes in to tell it, like, yeah, if it looks the same, it's the same. So it will take basically, and you can really, transform from one thing to another. Yeah, so here you can see that it validates that. So that's a really useful feature for when you have a process in your system that needs to take data and turn it into something else. Super clear, and you can see where it's used and how it works more visually clear than any other way I've seen this done, actually. This is a classic thing in transformation things like Microsoft BizTalk or something, and I think this is actually better than that. Then another thing that's important to notice that Hans didn't really point out clearly in the view model is that what's the difference between, if you have the attributes up there, if you look at them, they copy that data, right? So details here, because you have the blue view model class, it will create copies of detail. So what if you just wanted to copy a link and not copy what the link points to? Well, then you have it exactly like an attribute. That is an attribute, it's just that it doesn't have the object at the other end. If you want to copy the single link, what it's pointing to, you just add a blue view model class and it will make a copy of the object that it points to. The same goes with multi links, if you can't remove that, you don't have to do it, Hans, but if you remove the blue thing there, you will get a copy of the multi-link, not new objects at the other end of the link.
Yeah, and
So
that would
really
mean,
powerful.
and if you copy a multi-link that's single in the other end, it will strip the objects from the other end. So that's one consequence. But good that you pointed the transform operator out. I think it's a bit undersold, but it's a really powerful operator to do this kind of transformations. Because what we could do here is to take a thing and make it into an order. Since we made them match in, and this is a thing from JavaScript and untyped languages, and the concept of duck typing comes from that. If it walks like a duck and looks like a duck, it is a duck, and that's the concept behind the duck type principle. That's of course horrendous and totally criminal to do if you want to keep track of a system that grows. But as we now have strongly typing along with it, we can get the very pleasing effect of doing this transformation declaratively, so we don't have to do it imperatively to copy one thing and move it over to another type. So it's very efficient, I would say. Let's see if we can make this work then with autoforms. Create autoforms, and let's take the action that we called try deep clone and rename it to try to transform, and instead of calling deep clone we would call transform, and it requires a view model and a destination object, because now we can't I guess we could, but since we might want to do a specific subclass or something, we send in a new
it would be restrictive, I think, to just be able to do it with one type. I mean, duck typing, the whole point of it is being like loosely typed.
Correct.
So that's why we send in the object.
So it will create an order, and it will follow this recipe and do the transformation from there. Let's see if that works. Save that one and refresh this one. And if I have this one and try to transform, I got something. Let's see what I got. Order seeker. I got a new order, and it got the date time. It didn't get the sum string for some reason. Let's see the details, and here it should have gotten the details as well. So let's not debug this now. I'm sure I did something out of spec. If you can see straight away, Lars, that would be great. But I can't. Unless we this one might be. Oops. No, it should have copied more things. So let's go back to the documentation at a later time to see. I'm gonna follow that up with a description, not to lose time.
It definitely works because it's in production and does thousands of transformations a day. So
yeah. So that's the clone, and then partly the
So
transform.
Hans,
Yeah.
would the clone then be what I would call a transient copy that allows a user to interact with and manage the persistence?
You could use transform for that. I guess if you have a similar object structure that's transient, that I think that you have done for some use cases, transform would be a good way to do the copying.
Yeah, I do it all the time. I'll go through a list of something, and it'll be for some kind of specialized query or something, but it's all done in code. It's not done speculatively, which is
I've done it. You can put it in basically, if you say like do this, and in the root object of the view model that is supposed to open, you create a new object and you transform data into it, and then it will be showing. If the user then presses cancel, it will all be rolled back. Nothing happened. If the user does something and press save, it's saved. So it's really, just like anything else. You just create an object. This is just a way to create more objects by using a template, basically.
Yeah.
So in the save operation, then that takes the clone and stores it back in the original?
No, the clone is just a copy, and it has used the pattern to know how the new copy should be populated. And as it sees that the original follows associations and the template follows associations, it will create new objects. So if these were defined as persistent objects, they will be new created persistent objects that are copied from the old ones. And when you save that, that goes into the database. But if you instead would use the transform, and you take it from a persistence object thing and transform it to a transient thing order, and then you would get the effect of having it copied. Then you could potentially take the transient order and send that into the recipe transform, following the same recipe, possibly a new one that's typed on something else, and creating back transient objects if you want new ones. It will create new objects of this. So it's not tied into anything really deep. It's just a pattern operator. It follows the view model and does the operations that it has been instructed to do, namely create and copy attributes, create objects and copy attributes.
And the power in this is being declarative, right?
Yeah. So that's a good thing, because then whenever we want to figure if can I really drop some string, oh, it's in deep clone. Yeah, I forgot about that. So we need this because we copy this in these use cases, etc. So it's really good to keep track of everything and know where things go.
And and transform, because it's not creating everything new, can also be used to update a structure. I've used it in several occasions for accumulating, like if you want to build statistics from something. You have something and you want to process that and you want to accumulate and update stuff. You make one of these view models, and then you just you use that as a way of aggregating and creating new summary objects. Also very much simpler than trying to put all this in code, because it's just spot on. You just add, you can easily navigate, you add, you want to create a list of something, and you can navigate away and pull things into a summary object much easier than trying to describe all that in code.
Yeah.
Right. Statistics are a great example of that, I think. I do summary data of, say, a sales category or something over a time period. And so, currently you have to, I have transient objects, and I create an instance of it, and I go into the base classes, and I find all the appropriate matches with OCL, and then process all that data, and then boom, here, this transient object has that summary that you need.
So in this case, when some things change, state changes, and then you might have a server-side view model that processes it, or you put it in the async queue, and that takes the object, transform this from this to whatever it needed, and it can update also. That's the beauty of it, the transform thing. It doesn't need to create a new one. You can just run it again and again between two objects, and it updates their object.
Yeah, and that's the explanation to why we didn't get any order rows, because it won't actually create the order rows details unless we have explicitly said that it should in the view model. Isn't that so, Lars? Since we can send in if we were to change this, I'm gonna, now that I know what's wrong, I might as well just make sure that we get it right. So if I look at the outer form for, what did I call it? I call it the order. And I'm gonna do details. I'll save that one and then.
But you didn't get some string either, so.
No, that's true.
I don't know. I don't know exactly what's going on.
No.
But I think it's all in the wiki how to use it.
Yeah. So,
and you can do all sorts of everything you can do in the view model that creates a result. You can do in this one. You can calculate, sum, aggregate, do whatever you want to just end up on a duck type value, and it will be also very nice to you. It doesn't have to even match, I think, the type. It will just transform through string and do what it can.
Yeah. Yes. Let's move on.
Yes.
So Tajson is again one of those things that heavily rely on view models, declarative descriptions of object transformations. So what do I mean? Well, instead of doing a clone or transform here, we can actually change this action to give me some JSON, and instead of doing this that we did before, we would call Tajson as Tajson, and this one expects a view model name and a boolean for if it's going to skip the empties or not. Skip the empties is sometimes you want to represent attributes in your JSON even if the value is null, and sometimes you don't. So and that's very common for APIs to be picky about this. Well, you can't send the attribute if the value is null, etc. So let's use the exact same view model. It's called Thing Deep Clone 1, but let's not get hung up on that. It's just a pattern to follow an object structure starting in this object. And let's say that we're gonna skip the entries, let's say false on that one. So this will return a string. And what we're going to do with that string? Well, we can assign it to our some string attribute, I guess. So we have an object. We're gonna use a pattern to fold out JSON, and we're gonna get a string back that we're gonna assign to our own sum string. Let's see how that turns out. Yeah, whatever. And view all things, if I have this one. And give me some JSON. So as you can see, it followed only the things that I put in the view model, and this is a super quick way to know how to pick and choose what you want to pull out from your model to get some specific maybe a schema controlled JSON that needs to be sent to someone else. So this is a really powerful feature, but getting JSON is one thing. The really
just mention, Hans, that there are settings that you can use for the view model, tag values. You don't need to show it, Hans. That lets you control some of the flavors of how you want the JSON to be rendered or created.
So since this is a important feature, we have some support for it in the debugger as well, the Tajson workbench. So if I were to look up all my thing here, got a thing here, and this is new, one of the new things that I wanted to show in the debugger. Before today, or before yesterday, all these 3 windows needed, they really had a little combo box choosing from the values in the result, but that turned out to be really cumbersome and problematic for different reasons. Now you can just grab an object from wherever and drag it into your view here. So now there's a root thing here that you can basically pick what pattern you want to follow. If I want to follow the view 1 thing and call the operator as Tajson, I will get a JSON for that, and of course now the sum string in itself is a JSON, so that turns out like that. And if I were to follow this one, it looks slightly different, and it's the attribute 3, I guess, that will that's read-only, and read-only in Tajson means that it will be suppressed, so that's one way to suppress things. I guess it is, anyway. Let's check that. View all things and view 1 thing, and attribute 1 is... Okay, I'm not gonna go into that rabbit hole. Not sure why that would be. But the 2 other operators, apply Tajson and merge Tajson, they are also available as operators on the object. It's pretty cool because that means that you can get data back and sort of push it back into the object. So if this integer is 1 now, and I were to change this to 3 in the text, Tajson text, and apply that, that would update to 3 there. And if I were to change this long text to a valid JSON like that, and just applying that, that would update immediately there. And it will also do things like apply is that it will try to mimic deep multi-associations. So if I were to send in, make this list longer, and now it's 3 over here, but as I do apply, I would have expected it to... There's something fishy going on there. I can't really put my finger on.
Comma too much, or is it?
No. The thing is that it will always use the first attribute in the JSON as a key. So it has to be a unique key in order to denote it as a unique object. So this is 1, this is 1x, and this is 1f. That's the thing. So now they are added. So this was what the apply does. And what's the difference between apply and merge is that even if this list comes back a bit shallow, these were not mentioned for some reason. Apply would make them equal by deleting stuff over here. So now they were deleted. But that's not always what you want, certainly not with distributed systems where multiple updaters come from different histories and send things in. So then it's much better to first make sure that everything is there, and if something is missing, use the merge. The merge will try to make them equal, but it won't delete anything. So if there are new things like D and FF with merge, those will also be created, even if the other ones. So that's it will behave differently if you change the key. Right. So 3, or is it even 3 very different ways to use view models as patterns to get things done without breaking your neck coding.
Hans, a couple of follow-up questions and statements. I think we have the ability to accept XML too, don't we? Tajson?
Yeah, so pretty much the same thing here as JSON we can do with XML, I think. But
yeah, and then just one way of using it, I use it extensively in an API implementation by creating JSON, this as Tajson, and then sending it to another system, and then when I get the data back, I use one model, a view model in this case, for like shaping my request, and then I use another one for receiving. And in that case, I don't trust the data really at all, so that's why I always use a transient object, and then I use the apply Tajson to that one. So it takes all my input data and like expands it into a structure. And then I can do some validation on that. And then I use this transform feature that we just looked on to transform it into the destination place where I want it. 2 really powerful ways to implement APIs, because you can really see what's going on. You can receive data, turn it into objects, and then you can use OCL and all the other features. And then without really doing anything else, you just transform it to the destination. Super, super nice way of implementing transformations and APIs. Before this, it was, I think, doing APIs is quite messy. This really puts the declarative approach to this whole process of interconnecting systems.
Yeah, and there's quite a lot of text on the Tajson approach, because when doing these kind of back and forth between objects and JSON, you will always run into situations where you need to do some massaging, or should I create an object here or should I not? Or should I look up an object rather than create one? And there are all kind of functionality for getting that into place with certain operators. Yeah, cool. Good. So we very recently, this week, added a UI allowed flag as well as a REST allowed flag. And so, but while we're in the debugger, we can take a look at the thing that I wanted to show for, let's say I have a object here and drag it over here, and I look at view model thing 1. I can get the view model rendered here, so that's good, you might say. But what's even better from today is that we now can make this, as I do my updates here, of course I'm able to now this one's come from the wrong place, so I'm gonna save that one. It didn't have the, I need to start it this way. One second. Start the debugger this way. I'm gonna close this window because that's modal, and I'm gonna look up things. I'm gonna drag that one over here and view one thing. Now I'm back where I were, and what I was about to say, that if I change things here, I have from before been able to do a reread model to get the update into here. But the problem with that was that with the reread, we nulled out the root object and everything, and you had to do that all over again. It was annoying. So that has been improved, that a reread model will keep all these things. So that's good. If you do major changes, you might need to reread. But now there's a way to just simply reload this view model so that the changes you do here gets into here directly. And as that was doable, we also added the hot reload checkbox. So now they are sort of linked. If I move something here, the UI will update immediately. And here I can test out how it will work in production with buttons and things like that. So if I want to add some logic here, and the button shows up immediately and I can press it, of course it doesn't do anything. But if I do something here like details, add detail, create, and press the button, I directly have the functionality. So that will really help when you're in a tight loop and you want to fix things up, like maybe you're doing a REST API and trying to get the other server to understand what you're saying, and that's always cumbersome because you will always do it wrong 15 times. And if you need to press start and test it in the application 15 times, that you will lose a lot of time. But this way you can immediately get the button to do the operation and see what happens and work with live data. And of course, as I started the debugger this way, I'm free to use an MDriven server as the back end or SQL as the back end if I want to get the live data from there. So that's, I think, super cool. Fast way to work.
Yeah, really cool. This is like when you're in C# and you can backtrack the execution point a few rows and then make some changes and run it forward again.
Yeah. So this is...
So we're getting closer to interpreting the whole model. And here you can see that it's interpreted and not turned into code first.
Yeah. So this is a bit like they do brain surgery, right? You need to stay awake so they know where to, if they poke on the wrong place. So this is brain surgery, MDriven way. All right. So that was...
Now we will run out of time again.
No, goddamn. Okay. Well, there's always one more thing.
A good explanation. Clone Transform, Tajson, they're all super useful features. So I think this is a good recording too.
Yeah.
How to use these things.
Yeah, okay. Yeah. So, well, we won't give up. We will eventually work through the list unless the list keeps growing. Which it might.
Yeah, but
that's a good thing.
This really points to how much you can do with the view model because it's basically just a hierarchical description of how to turn a class, like data from inside into something that is a facade or to something else. And this is transformation, facading, cloning, Tajson, APIs, everything.
Yeah,
so,
and there was no way that we could have thought this out from the start. This is really a stroke of luck that the view model has turned out to be this generic description that no one else has, at least not that we have seen, have conceptualized and used in this way. But of course, everyone will use it something like this in a very, very near future. So this is obviously the way to move up from a single object into a structure of objects that might be filtered and might be transformed. And whoops, you're on a whole new level to throw things around that are on a much higher level of abstraction than merely the model objects. So if you would have asked us 5 years ago that this was where the view model were going, we wouldn't have known. The root driver for the view model was really fetching, because as all frameworks suffer from it suffers from delayed fetching, and that really kills performance. That objects in a grid will be fetched one by one unless some developer have told the view that it should fetch these smart because it's going to render things here. And of course, that what most people do today. They code things so that the things are fetched before they are rendered. But as we have the view model, we can do that automated to analyze what's in the view model and fetch things smart. So there's and that really never fails. But a developer that's going to follow a pattern quite often fails from between versions of the software. Yeah, super. Thank you for tonight then, and we will. I will talk even quicker next time.
Thank you very much, Hans.
Yeah, thanks.
Thank you.
Thanks.
Yeah, brilliant. Thanks a lot.
Thanks.